through 08, we're measuring damping in a vibrating ruler. Our team is myself, David Matthew, Emilio Ortiz, and Kasim Hassan. This is our experiment setup. We set up a simple cantilever beam using an ordinary aluminum ruler. We fixed it on one end and kept the other free. We put a slight displacement and then let the ruler vibrate freely. We recorded this on an iPhone 16 camera and used the tracker app to find the data. Here you can see a video of the experiment we did. There's the initial displacement and then the vibration, as well as how the cantilever beam was set up using the ruler. Here the tracker app gave us our data and followed the vibration at a certain point. From this, we exported all the data to a Google Sheet. We set up a plot of the displacement versus the time from 2.7 to 3.2 seconds. From this, we found our tau and we found our delta, which we used in later calculations.
Okay, so here's our theoretical analysis. It shows us the given variables that we used, as well as the assumptions and equations that we used or derived when we were calculating the experimental, or rather theoretical values. Now, this is a sample equation of just how we calculated the equivalent stiffness, which came out to 532.06, and it just shows how much the ruler is bending. All right, and so this is just the logarithmic decrement that we used to find xi, as well as a few other equations that we used. We determined that the damping ratio was equal to 0.0016. We decided that the natural frequency was 85.56 radians a second. The equivalent mass was 0.071 kilograms, and the damping coefficient was 0.1996. This damping is measurable and influences how the ruler stops vibrating over time. So now here are experimental results using all the equations we found and derived. We put them into a code, and you can see that our experimental values are a little bit bigger than the theoretical. Our values in the experimental graph damp much quicker than the theoretical, showing how the damping influences it much quicker than anticipated.
Using tracker, our limited video frame rate, so there are oscillations that might be missed. We also have human error with initial displacement, along with the textbook maybe not holding it down as well. We also have ruler boundary conditions that were not perfectly fixed to what angle we needed. And also simple damping issues or environmental factors can affect it as well. In terms of reflection, we learned a lot with how ruler vibration matched the theory that we calculated as well. We get to see that comparison. Using tracker, getting more practice, and that really helped. And also calculating that log decrement and using octave. These are all things that we learned together as a group. And we learned teamwork, working with processing data and setting up and all these things. And on top of that, to kind of finish it off, obviously there are errors and limitations to everything, but learning more about it, gaining confidence in these experiments have always been helpful. Thank you, everyone.